Question 6 is vectors. This is a C4 question and this is completely new. It has no counterparts in C1, C2 or C3. The first question is you have to find the constant. In order to find the constant, you have to make sure you understand the basic concept of point of intersection. In vector, if you have a line like this and suppose it passes through 2 points starting from A and B, and there is an origin here. This is OA, the vector, and this is the vector OB, and this is the vector AB. By the triangle rule, it says these two vectors going in the same direction is equals to this opposite direction. Vector OB is given any position vector on the line. We don't know what this position vector is. This is equals to, this is the starting point OA plus AB. This is a basic concept of vector called the triangle rule of finding the vector. If you don't know how long this AB is, if it does not have a beginning or an end, suppose AB is multiplied by a constant lambda, so this is lambda AB, it means how big this AB is, how long this AB is, we do not know. It can be anything. Depending where that AB ends, that would be the position vector of this point. So OB is the position vector format. This is written in this format: R equals to position vector of the initial point plus lambda, however long this line is, we call this the direction vector. It could either be parallel to this to give us a sense of direction, how long this is, or it can be on this line. So lambda is the scalar number that shows us how big that AB is. When we rearrange this in IJK format, it can be expressed as the position vector of any point on this line. Remember, this R is basically referring to this point. Let's get back to the sum. This sum is given in the IJK format. IJK format, that means this one here is the position vector. This is the position vector, meaning if there was a line, this was A, then it would be 8i plus 12j plus 14k, meaning the Cartesian coordinate would be 8, 12, 14, and that would be the position vector of A. We don't know how long this line is, wherever it ends. If it ends here, this is an unknown point. This thing is R. So this is R, and the direction vector of this, if this is B, any position vector, then this AB would be lambda of this. This is the direction vector, meaning same as this, which is I plus J plus K. That's it. So the idea is the position vector. If this can be rewritten in IJK format, we can know any point on this line, because basically R means the position vector of any point. The first thing I'm going to do for finding the constant, I'm going to write it as the position vector format. If you have a point A, then OA can be written as 8i plus lambda I, 8 plus lambda I plus 12j plus lambda j, 12 plus lambda j, then 14k minus lambda k, 14 minus lambda k. But OA is also expressed as a position vector of this point. If this is A, OA can also be expressed as 4i plus 8j plus ak. Remember, both of them are OA. So this line on which point A and point B lies, depending on a value of lambda, depending on a particular value of lambda, we can find the position vector of any point on that line, because after all it is the position vector format. So comparing I with I, all the lambda would be the same for this point, because it will end somewhere and that lambda represents a single point. Every lambda represents every single point. If I write I equal to I equals to I can get 8 plus lambda equals to 4, therefore lambda equals to minus 4. 4 minus 8 is minus 4. Similarly, this can also be done with this, so we don't have to bother that. Even that lambda will be minus 4. Every lambda would be the same for this point because it has to end somewhere. Every lambda represents every point. And now I want to find the constant a. K equals to k would give us 14 minus lambda, lambda is minus 4, equals to the coefficient of k here is a. Therefore a equals to 18. Then this thing can also be considered as OB because this is any position vector, and OB is also B 13 13. Again, OB equals to 8 plus lambda. Maybe you don't have to write this twice, but it's a good idea for presentation. It's easier to understand whoever is checking the paper. So let me write it down. 14 minus lambda k, and OB is B 13 13. That's the Cartesian point, so the vector would be BI plus 13j plus 13k. Let me check. Yes, it is B 13 13. Since point B also lies on that line, so I can do, now I want to find the value of lambda for the point B. It will be a different lambda. Since this is what I want to find, I'm going to compare J now to find the value of lambda for the point B. So 12 plus lambda equals to 13. Therefore lambda equals to minus 1, and I equals to I would give me 8 plus lambda, lambda is minus 1, equals to B. Therefore B equals to 7. So wait a minute, this is 13 minus 12, this should be plus 1, so this will be plus 1, this should be 9. Now it's alright. Let's restate the answer. Answer A equals to 18, B equals to 9. Question number B. Given that the point O is the origin and that the point P lies on L1, this is the equation of L1, they have mentioned it, such that OP is perpendicular to L1. Okay. So any point on this line L1 is giving the position vector. So I can call this arrangement as any position vector, whatever the value of lambda is, that would be the point. So this is actually the position vector on this line L1. So this time I can write OP as this. So OP equals to 8 plus lambda I. Remember, this is the position vector of any point on that line, and specific value of lambda will represent a specific point J, and this is 14 minus lambda K. Now this time one thing that we have is this OP is perpendicular to the line L. Whenever two direction vectors are perpendicular, we take the dot product of the direction vector as 0. That's the rule. If two vectors are perpendicular, the dot product of the direction vector is 0. This one is the direction vector for OP, and the direction vector for L1 is this one. This is the direction vector between these two. So the direction vector is this one, inside lambda, I plus j minus k. The dot product by the question, so the dot product would be between OP and that direction vector of this line, I plus j plus k. So it's a good idea to write it as a column vector now because it's easier to see. So this would be 8 plus lambda, 12 plus lambda, 14 minus lambda, direction vector of OP with the direction vector of the line L1. That would be I is 1, j is 1, minus k is minus 1. The dot product is 0. I'm writing this in column vector format. You can either write it as ijk or column vector. I'm writing it as column vector form because it is easier to see here. Dot product means you take the dot products of I, you take the dot product of j, you take the dot product of k, meaning multiply the coefficients of I plus multiply the coefficients of j plus multiply the coefficients of k. So dot product of 8 plus lambda with 1 is going to be 8 plus lambda multiplied by 1 plus dot product of j with j is going to be 12 plus lambda multiplied by 1 plus the dot product of this and this is going to be 14 minus lambda multiplied by minus 1 equals to 0. So 8 plus 1 plus 12 plus 8 plus lambda plus 12 plus lambda minus 14 minus plus lambda equals to 0. So 8 plus 12 is 20. 20 minus 14 is 6. This is going to be 3 lambda equals to 0. Therefore 3 lambda equals to minus 6. Lambda equals to minus 2. The question was, now that we know the lambda, we can find the point. The question was, find the coordinates of P. Okay, remember the general position vector is this one. So OP is 8 plus lambda means 8 minus 2, 6i. 12 plus lambda means 12 minus 2, 10j. 14 minus 2 is 12k. Therefore they asked for the coordinates 6 comma 10 comma 12. No, this won't be 12 because this is 14 minus lambda, minus minus plus. This should be 16. 14 plus 2 is 16. Okay, now it's alright. In question number C, we have to find OP. That means modulus. The modulus of a vector is OP equals to square root of coefficient of I whole square plus coefficient of j whole square plus coefficient of k whole square. That is the length of OP. So modulus of the vector OP is the length of OP. So 36 plus 100 plus 144. This would be 136 plus 144 square root of 280. Oh, this is not 6, this is 16. So this should be 256. So let's get back. Remember to write clearly because this is a common copying error. So 36 plus 100 plus 256. That would be 392. This would be 392. Now it's alright. The mark scheme done very with little steps. You have to go through the entire step. Remember, this is the first step. A equals to 18, B equals to 9. It's correct. So they use the dot product in the column vector as well. So lambda equals to minus 2, 6, 10, 16. Okay, this is the mark distribution. Remember, this is not how you present your answer in the exam. This is just a guidance of the mark scheme. And OP square root of 392. I wonder, do we have to write it in the simplest form? Let's see the examiner's report. Although this seemed a very fair test of vector work and was well answered by good candidates. Good candidate means the people who did good in the exam. So not many people did well in the vector sum. Okay, it was the poorest answered question. Oh my god, the vector question was the poorest answered question. You might expect something in the next year, a vector question that would be checking the concept, the basic concept of vectors, perhaps the same concepts. This is a warning for the teachers. With a high proportion of candidates unable to gain more than the odd mark in parts B and C, meaning 1 or 2 marks. In part A, many candidates found one correct value of A, having found lambda equals to minus 4, but then used the same parameter to find B. You have to be very careful about that. You cannot use lambda equals to minus 4 for both. Then in B, the majority of candidates were clutching at straws, meaning they didn't know what to do, and even some who knew that dot product is 0 could be used had very little idea what A and B represented. That means they just don't know vectors. A generous method mark in C was often as much as many candidates gained from part A. Okay, so remember, you need to study vectors. Vectors is the basic. So people who do bad in C4 is not because it's difficult, because they just don't study.